This is the third part of the tutorial about advanced topics. And here we are going to talk about key phrase generation in information retrieval. So key phrases distill the most important information from documents, and we saw that they are useful for many applications in natural language processing. So the question is, what about using key phrases in information retrieval? And more precisely, are key phrases useful for improving the information retrieval effectiveness? One straightforward approach to use key phrases in IR is to use them to supplement document indexing. The idea is to add automatically generated key phrases to documents before indexing, which can be seen as a document expansion technique. Expanding documents with key phrases should improve their retrievability by mitigating the vocabulary mismatch problem. And disadvantages are that we get a larger index size and a possible document drift in cases where documents are expanded with irrelevant key phrases. Interestingly, using key phrases for information retrieval provides an extrinsic evaluation framework for key phrase generation and extraction models. We have seen that evaluating key phrases is not an easy task, and there are many limitations with current evaluation metrics. Thus, using an extrinsic evaluation framework allows for a better understanding of the limitation of current key phrase generation model. But before going into that direction, one may ask, why bother doing document expansion, as we now have neural retrieval models that provide semantic level matching? First, scalable retrieval engines use exact term matching to perform an initial round of retrieval, and then use a neural model to re-rank the set of retrieved documents. Improving the quality of the lexical retrieval using document expansion is therefore still relevant. Also, in a zero-shot setup, results from the BEER benchmark show that neural information retrieval models underperform lexical models and that document expansion techniques such doc to query or doc T5 query achieve consistent improvements that are more additive to query expansion techniques. So this is an overlooked aspect of document expansion, which is that we can easily understand why a given document becomes more relevant for a query by looking at the expanded terms and even completing or correcting them if necessary. So there is an interpretability aspect of key phrase expansion. So this figure shows the framework for supplementing document indexing with key phrases. We use a key phrase generation model to produce key phrases from each document in the collection. Key phrases and documents are then concatenated into expanded documents, which are indexed by the search engine. And by enriching this indexing, we expect more relevant documents to be retrieved for a given query. And to assess the usefulness of key phrase generation for information retrieval, we conducted a series of experiments on the NT-SCIR2 test collection that is made of scientific texts, so abstracts. These documents also include author-provided keywords, and we used two ad hoc retrieval models implemented in the Anserini toolkit, BM25 and BM25 with relevance feedback. And two seek-to-seek key phrase generation models are compared here and contrast against an unsupervised key phrase extraction method. This table here shows the mean average precision of the retrieval models on two indexing configurations, indexing title and abstracts, and indexing title, abstracts, and author keywords. And for each indexing configuration, we further expand documents with key phrases and evaluate their impact on retrieval effectiveness. What we found is that key phrases are helpful and they improve the retrieval effectiveness. And interestingly, there are gains when using both generated key phrases and author keywords. That means that they are complementary. And also gains provided by query expansion and document expansion are additive, which indicates that they provide a different but complementary relevant signal. Let's now take a closer look at the usefulness of present and absent key phrases for information retrieval. Key phrases may appear or not in the document, and the distribution of present and absent key phrases in manually annotated key phrases is approximately 60 to 40%. Here is an example of document from the NT-SIRE2 text collection, and we see that some key phrases occur in the document, such as meta search and search systems, and others don't, such as information sharing. These key phrases depend on whether they occur or not in the document will have effects. Sorry, the fact that these key phrases occur or not in the document will have different effects on retrieval effectiveness. Present key phrases will modify the term weighting scheme, while absent key phrases will act as a document expansion technique. So the question we are interested in here is to which extent present and absent key phrases contribute to improved retrieval effectiveness. But before doing so, we have to define what makes a key phrase absent. So in the literature, key phrases that do not match any contiguous subsequence of the source text are considered as absent. And from an information retrieval perspective, this is not precise enough because stemmed words are used to index documents. So absent key phrases can have some or even all of their words actually occurring in the source text, and therefore they act no differently from present key phrases. So in the example shown here, information sharing and share information would be considered the same by the search engine. And only 3 new words are actually added to the document: retrieval, behavior, and support. This is why we need to redefine what absent key phrases are in the context of information retrieval. To do so, we propose a finer grained categorization scheme called PRMU, where absent key phrases are divided into 3 subcategories that are reordered key phrases, which are key phrases where constituent words occur in the source document, but not as a contiguous sequence. For example, information sharing. Mixed key phrases, which are key phrases from which some, but not all, of their constituent words occur in the source text. For example, information retrieval and users' behavior. And unseen key phrases, which are key phrases whose constituent words do not occur at all in the source text. For example, retrieval support. So in contrast to the binary present and absent scheme, this PRMU scheme draws a clear distinction between key phrases that expand the documents and those that don't. Here we show the distribution of gold key phrases under the PRMU scheme for 3 datasets containing scientific abstracts. And what we observe is that they have very similar distribution across datasets, with approximately 40% of absent key phrases. The last column here indicates the ratio of unseen words, which is the number of key phrase words that do not appear in the document and therefore contribute to their expansion. These unseen words that occur in key phrases from mixed and unseen categories only represent 20% of all the key phrases words. So here we evaluate the effect of indexing key phrases from individual PRMU categories on retrieval effectiveness. Again, we use 2 retrieval models implemented in the AnswerINI, and we use the NT-SIRE2 test collection. This table shows the map measure for the different indexing configuration with individual PRMU key phrases and some combination of them. What we found is that the largest gains in retrieval effectiveness are obtained with mixed and unseen categories, and that despite a very small number of key phrases belonging to these categories, this results indicates that expanding documents is more interesting than highlighting key phrases from an information retrieval point of view. So absent key phrases are more important for information retrieval. Another result that is not described here is that we analyze the output distribution of key phrase generation models, and we saw that they are heavily skewed toward the present key phrases. This means that state-of-the-art key phrase extraction models produce almost exclusively present key phrases that are not that useful for information retrieval. So future works should go towards generating more absent key phrases, and therefore this line of research is greatly needed. So if you're interested in evaluating your model, your key phrase generation model through the task of document retrieval, these slides displays further links that may be relevant for you. And this is the end of my part. And the next presenter will be Rui. We will talk about domain adaptation for key phrase generation.